So we're going to explore a reminder of how logarithm calculations work so that we kind of understand what we're talking about here, and then how to actually solve equations with logs and exponents. So the first thing to remember is that a log is just a rewritten form of an exponential expression. So for example, if I know, and if I were you guys and you struggle with this, I would actually use maybe this single example on my paper. 2 to the third equals 8. You guys are good at recognizing the pieces of this, and actually, see, we'll color code this a little bit. So you have your base highlighted in green there. 2 is our base. We have our exponent, which is 3. And then we have 8, which is the value of the power. So like what the power calculates to be in the end. If we rewrite this in log form, log was specifically designed as a function to go with exponents and write them in a different way. This would be log base 2 of 8, and we would calculate that to be 3. So notice they're giving you different information. They are basically giving you this. It would be like them writing this all the time and leaving that empty. So they wanted a notation where they can write it this way, and we can have a way to put that in the calculator or know what they're asking us for without just leaving a portion of this empty. Instead, we could write it all on one side. So notice where the pieces went, because this is going to be a key to being successful here. The base is still the base. This is literally said as log base 2. But the other given piece of information is the answer that you would normally get in the exponent problem, the value of the power. So we would say log base 2 of 8. And if you were asked to calculate log base 2 of 8, you would really be doing this. 2 to what power equals 8? Can I figure that out? And you're calculating the exponent. Okay, so the exponent is actually the answer to the logarithm. Okay, so as we go through these, when we look at log base 3 of 9, in our heads we're thinking 3 to what power equals 9. And so another way to think about that is to kind of put a little x there just to hold a spot. You're not really solving for x. And 9 can actually be written as a power of 3. I know that 9 is 3 squared. So the exponent here must be 2 to match this other exponent. So log base 3 of 9 is equal to 2. In other words, 2 would be the exponent that I would use on 3 to get a value of the power as 9. So let's try again here with 5. So again, my thought process, 5 to what power equals 125. And a way to look at this algebraically, 5 to the x power, can I rewrite 125? I can, as 5 to the third. The power on 5 must be 3 in order to obtain this. So log base 5 of 125 is equal to 3. In other words, an exponent of 3 is what I would use on a base of 5 to get 125. So the next question says log base 1/3 of 27. Do I know a power of 1/3 that will equal 27? And the fraction here might bother you. So notice though that 1/3 uses a base of 3, and I know that I can make 27 with different powers of 3 also. So a small reminder that a fraction with a 3 in the denominator is the same as having a negative exponent on that 3, but I still want to know what other exponent I can raise it to, so I have that x here. 27 is the same as 3 to the third power, so I want this to equal this. So when would negative 1x equal 3? It would work if x was negative 3. So negative 3 is what I would want to be my exponent here. And what I'm saying is log base 1/3 of 27 is negative 3. In other words, if you have a base of 1/3, the exponent I would use on that would be negative 3 to get an answer of 27. Okay. So log base 5 of 1. So I'm going to use, again, the same idea. Do I know a power on 5 that would equal 1? So a small reminder for you guys that 1 can be any base to the 0 power will give me 1. So I can have 5 to what power? And I could rewrite 1 as 5 to the 0 power, so I must be using a power of 0 on 5. So log base 5 of 1 is 0. 0 is the exponent I would use on 5 to have an answer of 1. So then I have log base 2 of negative 4. 2 to what power equals negative 4? So you might be thinking about it, and you guys might be like, oh yeah, 4 is 2 to the second power. But here's the issue. How do you get negative here? 2 to the second power is not negative 4. Negative 2 raised to the second power is not negative 4. There actually is no exponent rule where an exponent takes a positive base of 2 and changes it into a negative. So this actually can't be solved. And there is no solution for this calculation. Okay, and I actually want you to make a note here. You actually can't calculate log of a negative number no matter what the base is, because in logarithms the bases are always positive and there's no exponent that changes the sign of a base. You can never get a positive number raised to a power that will equal a negative answer. So we're never able to answer this question based on how the logarithms were defined. So that's not going to work. All right, so next one, log base 3 of 0. So 3 to what power would give me 0? And again, think this through. If you raise 3 to positive powers, you're just going to get powers of 3, which is not 0. If you raise 3 to the 0 power, you actually get 1, so that's not going to work. And if you raise 3 to negative powers, remember that really just gives you a fraction, but still not 0. Again, there's no exponent that allows something to be changed from having a base of 3 into 0. Just like this last one, how there was no exponent that made positive bases negative. So again, this is going to be no solution. And we want to make a second note here. Not only can we not calculate logarithm of a negative number, but we can't calculate the log of 0. Again, why is that? The way they defined logarithms, they have a positive base, and there's no exponents that turn a positive base into 0. There are no exponents that turn a positive base into a negative. So this was a little review, a reminder of how log and exponents are related to each other up here, which will be really important in our solving, and a little reminder of how they're calculated. And one other reminder, because we're going to let you guys put some answers in decimal form, that in a calculator, some calculators allow you to enter in the base of the logarithm, but some don't. And a reminder that the log button on the calculator is a log base of 10, but there is a formula for logarithms. I'm just going to give it to you here. We're not going to talk a lot about where it came from, but the change of base formula says, let's say you wanted to calculate log base 2 of 3. And I don't know what power of 2 makes 3, but there is one, but it's like a weird power, like something with a decimal or something like that. Then I can actually enter into my calculator log of 3 divided by log of 2 using that log button on the calculator that's actually base 10. So this is just a reminder of how to put in the calculator in case you are using a calculator that's not a fancy graphing calculator that lets you choose the base of your log. Okay. So we're going to walk through solving 3 exponential equations and solving 3 log equations. And we're actually going to use 2 strategies while we're trying to solve these problems. And so depending on when you went over this in Algebra 2, you might have got a really good feel for it, and you might not have, depending on how last year went. So things to try. First of all, some things that you guys saw in what we were just doing. We were asking ourselves like 5 to what power equals 5 to the 0 power. And then we'd say things like, well, this must be 0. These exponents have to match. So the first thing to try in log or exponential equations is, can you just set stuff equal to each other? And then to do this, you really need the same base. So what I mean by that is if I have 3 to the x equals 3 to the 5th, x must be 5 and that equation is solved. So can I get the same exponent base? Or for logs, if I have log base 2 of x minus 1 equals log base 2 of 7, then I know that because these both say log with the same base, the stuff in here must equal the stuff in here because there's nothing else going on in the problem. So x minus 1 would have to equal 7 and x would be 8. So that's our first strategy every time because it's pretty simple. Can I make these look the same and set something equal? The second strategy we're going to use is we're going to rewrite, okay, into the alternate form. And so what I mean by that is if they've given me exponents and that's not working for me, can I rewrite it in log form? If they've given me logs and that's not working for me, can I rewrite it in exponential form? So for example, let's say I had 3 to the x equals 2, and I can't really solve this the way it's looking right now. If I rewrite this in log form, it would say log base 3 of 2 equals x. I have actually got x alone here. This is the answer. Okay, and then you guys can put that into a calculator the way that we mentioned before. And then with the same idea, let's say I have this and I can't just wrap my brain around what's happening here. If I rewrite this into exponential form, 2 is the base, 4 is the exponent, x is the value of the power, I now have x alone and x is equal to this, which is just 16 in this case. So sometimes if you rewrite them, you get x out of this really awkward position into a new position where you can actually get x alone. So these are going to be our two strategies every time we're trying to solve log or exponential equations. Can I set something equal to each other? Is it as simple as that, or am I going to have to rewrite it in a different form? So when we make these decisions for the exponential equations, if you look at all three of these, part B and part C are actually as simplified as they're going to get before I have to make a move, but not part A. In part A, I can add 5 to each side to get the exponential part alone. Okay. All right, now in all of these equations, I need to make a decision. Can I just set some stuff equal, or do I need to rewrite things? So first, is there any way in part A for me to set them equal? Only if they're using the same base. So the way they look right now, no, but I know that 27 can either be thought of as 27 to the first power or 3 to the third power. So if I rewrite 27 as 3 to the third power, I now have powers of 3 on each side, and now I can use the philosophy that I can just set those exponents equal to each other, and I can get that x is 5. When I look at part B, it's more difficult there because 5 is not a power of 4. 5 can only be written as 5. 4 can be written as 4 or 2, but neither of those are the same, so that idea is not going to work for me. So here I should try to rewrite it. When I rewrite this, remember, your base is your base. The value of the power is what we use as the input of a logarithm, and the exponent is the answer to a log problem. So this is good. This is actually solved. This is one way to write the answer. And then we're going to let you guys use a calculator. So if we're going to use a calculator for this, I was telling you guys before that the formula says we can take log of 5 if we don't have a calculator that lets us type in the base. Here's how we can transfer it to those values. So I'm going to use log of, oops, I have to put mine in backwards. So 5 log, so that's the log of 5, divided by 4 log, that's the log of 4, equals 1.16. So that's the answer there. And it might seem a little weird, but it makes sense. Like 4 to the first power would be 4. That's too small. 4 to the second power would be 16. That's way too big. So it's close to 1, but a little more. And so that makes sense for what we have. So same thing in part C. I've already got the power alone, but 823 is not a power of 5, at least that I know of. And so I would go ahead and I would rewrite the form of this. So I would write log, the base is 5, the value of the power is 823, and the exponent is 3x. Now in this one, x is not completely alone yet. You have to take one final step of dividing by 3. And so log base 5 of 823 divided by 3, that's one way to write our answer. Or we can get a decimal. Now remember, to get the decimal, you're first going to have to calculate this log, and if your calculator doesn't let you type in the base, you're going to have to do log of 823 divided by log of 5, and then don't forget to divide that answer by 3. So for me, I'm going to do 823 log divided by 5 log, what is that? That is 4.17, and that needs to be divided by 3. And so I get 1.39. So that would be my power there. So that gives us a handle on exponential equations, and then we're going to look at log equations. So with our log equations, the same idea, right? Now notice in none of these problems does it have one log set equal to another log, so I'm not going to be able to use this idea where we just set them equal, but you will if you have something like that. So what I'm going to do here is try to get the log alone and then rewrite it. So again, sorry for all the scrolling. I want to try and get it in this format where I have the log of one side and something else on the other, and I can rewrite it into something more solvable for me. So for the first one, the log is already alone. If I don't know the answer, I'm going to try to rewrite this. So 9 is the base, 3 over 2 is the exponent, and that would be set equal to x. So technically you've solved, but you need to see if you can simplify. So remember what these exponents are. 3/2 is like an exponent of 1/2 and an exponent of 3. And I'm just writing it like this to remind you guys that the fraction exponents means radical. So 1/2 means square root. If it was 1/4, it would mean a fourth root. If it was 1/3, it would be a cube root. And the square root of 9 is 3, and 3 cubed is 27. So that 9 to the 3 over 2 power is really 27. Okay. You guys have calculators too, so you guys could type that in if you wanted to. All right, the next one, here's my log, but notice it's not alone. So you need to isolate that first, just like we have in our previous functions when we've been solving. So I'm going to add 6 to both sides. I'm then going to divide by 2. And now I have the log alone and can't quite solve. I'm going to rewrite. So I'm going to get 6 to the 4th power equals x plus 1. And then 6 to the 4th power, that's a little bit big. So I'm going to go back to using my calculator. So let's see, 6 to the power of 4 is 1,296. And then I'm going to subtract 1, and I'm going to get 1,295. All right, my last one, part C, already has the log alone, so I'm going to rewrite it. 5 to the 2nd power equals x squared minus 144. So this is 25 equals x squared minus 144. And since the x squared is the only x in the problem, I can actually get it alone in square root. So that's what I'm going to do. So I get 169 equals x squared. If I square root both sides, I get x equals plus or minus 13. Now, one note about the log problems that I'm not going to make about the exponential problems is that you need to check your answers. Just like square roots, okay? Remember how square roots, we would work through it, we think we did everything right, and it's possible that we just make an extraneous solution? That's because square roots have limitations. Logs have limitations. Remember, you can't calculate log of 0 or log of a negative number. So you really have to make sure that all of these answers don't create this situation if you plug them back into the original. Okay, if I plug 27 back into the original, I would have log base 9 of 27. I don't really need to do the problem. I just need to make sure that that's not 0 or a negative number. So here it looks good and I'll keep my solution. What about for part B? If I plug 1,295 into there, I get 2 log base 6 of 1,296 minus 6 equals 2. This is not 0 or a negative. It's good. So I can keep that solution. Okay. For part C, let's check. So for positive 13, if I plug in positive 13 and square it, I get this, which gives me log base 5 of 25. This is not 0 or a negative, so it's good. What about negative 13? Well, this actually works out fine. Even though 13 itself is a negative, when I plug it back in here, I get the same work that I would get for positive 13, which gives me log base 5 of 25 equals 2. And again, it did not create a negative inside of the logarithm or 0. So this is good as well, and both of these work. But you need to check because sometimes your intercepts will not work. It's very important. All these functions that have certain limitations need to be checked. Okay,